Welcome back, everybody. I realized that it was a very short break and probably you had a lot of questions for the speakers, but please do know that you still have the rest of the day to be able to approach them. So I would like to start now with the easy research track. Welcome to everybody here. Welcome also to the online participants that are following this track by live stream. We just had a very interesting plenary session and, of course, the interesting keynotes from Wijnand IJsselstein. And right now, I want to introduce to you the scientific director of EASY, and his name is Wim Nuiten. Wim, thank you. The floor is yours.
Yes, thank you, Jolanda, for the introduction, and good morning to you all. So on behalf of EASY, welcome to this research track. I'm personally extremely pleased that this research track, as the summit as such, is on human-centered AI. The thing is that the AI research at TUE is based on three main pillars. One pillar is on engineering systems, and we are very well known for doing research on that. The other pillar is on data science, and again, we are in the world very well known for doing that too. In fact, in all polls and questionnaires that you get on the strength of TUE, data science tends to come up on top time and time again. Now, the third pillar is on humans and ethics. It's on human-centered AI. And unfortunately there, it is a relatively well-known, well-hid secret that TUE has world-class researchers doing world-class research. So I am thrilled to see
for the next talks, and the next speaker is Emilia Barakova. She will be speaking about pain and stress management using smart connected systems of social robots and wearables. Emilia Barakova, please.
Hello, can you hear me? Okay, thank you very much. I'm Emilia Barakova, and I will talk about our research on pain and stress management with using AI, and artificial intelligence is used in many different ways in our research. Starting from the technical aspects, what kind of algorithm to use here and there, but also some social aspects, how to not let people overtrust it, rely on it, and so on. How I go to the next slide? So we are working with several user groups, which are children with autism or very young children, stress and pain management by people with intellectual disability, and some are with very severe intellectual disability, and also persons with dementia, could be also advanced dementia. All these groups of people have several features. Well, they have difficulty to self-report, so we wouldn't know how they are feeling of pain or stress or engagement can be seen, can be understood. That's why we need a lot of different measurements, and especially taking physiological signals and processing them, mainly with different artificial intelligence methods, help us to understand these people, to attend to them at the right moment, and eventually help them alleviate the bad condition they might be in. I will just feature several projects and pinpoint several moments where we use artificial intelligence. These projects are about persons with dementia, who on the left side you see elderly person caressing a plushy thing. Actually, within this fur of a sheep, there is a robot, the so well-known Pleo robot, which is connected to the screen, which you see a small part of the screen. And on this screen will come more sheep if this virtual sheep, this robot sheep, is caressed. This project was made to increase the engagement of people with dementia, which sometimes will have very boring life in facilities when they will not have a lot of attention due to busy personnel. Another project which also relates to that is featured on the right. Well, here the robot is naked, it's itself. But in addition to that, we added physiological measurements to measure the level of engagement of people who are interacting with it. And we are distinguishing between the social interaction, but usually the social interaction was facilitated by the robot. By persons with intellectual disability and visual impairments, often those are comorbidities. Well, these people experience much more stress than an average person. If something negative will happen, for example, the caregiver will not bring them to an event which was promised to them. They are afraid that it will never happen again, so they need to calm themselves. They feel very anxious and unhappy. So we were providing several techniques to help them relax and help them feel more comfortable. So the several stress techniques which were used already, and they have the names of doll blocks and big chair, and they relate to the object which is used for the therapy or for the treatment, and it is about the robot helping them to search for the right person they need to relax them, or the robot shares experiences when similarly happen to it, how he deal with it, so eventually they can give some clues to the people with disability to be able to also use this technique. And a beach chair is one technique in which they just do mindful breathing to relax themselves. Well, with people who have severe intellectual disability, even such a simple conversation was not possible. That's why we developed a system. Actually, we started about 10 years ago, and the 2 PhD projects already have passed on that. We developed the so-called smart sock, which measures physiological signals and transfer it to a tablet when the stress level is visualized. I saw that several companies, actually we give the development to some companies, and now I saw the Design Week, somebody already produced smart sock in a different, more commercial shape, of course, which is a great development. But the main idea here is that with detecting the physiological signals, we can signal a caregiver to know that the person who has disability is not comfortable, has some pain or some stress, and they can attend to it. Of course, the ground truth we get from the therapists and caregivers, but sometimes a new person has to attend to them, and sometimes the signals, the outside signals of pain and stress are not easy to detect, especially by some user groups. So, well, these are more details on the project, how the first sensors we developed were helping the communication between the caregiver and the person with a disability, and the visualizations, what is the meaning of that. But I think I shouldn't talk about this part a lot. I would rather like to inform you that to get the connection between the shimmer sensor, or the sensor we have for detecting physiological signals, and the app is just not straightforward. We just visualize them. We use different machine learning algorithms to decide whether the person really has pain or stress, or whether it is just some positive arousal. If you want to just have a glimpse, we used a random forest algorithm, and well, first our results were very bad, but then we used a different feature extraction and other methods, and until our reliability grows up. Well, I have passion for robots, and especially social robots. So I was thinking, oh, this is a really great development. We can measure pain, we can signal it to a screen, but maybe also the screen, well, if it is more animate or human-like, can also react to that. And well, I decided to connect that also to a social robot. And because this started first with a project with very young children who had operation and may have pain, so we choose a robot which is appropriate to them. It looks like some kind of animal. Some will say rabbit, and the other goat. So the physiological signals are not only visualized to an app, but also sent to a robot, and a robot, through another set of machine learning algorithms, kind of reinforcement learning techniques, will decide how to behave in a certain moment. So the robot is kind of a therapy, but also we can get also additional information about the state of the child. If the child is really squeezing or being negative to the robot, probably have also some negative feelings. This project was possible because of the funding for TO, which was unfortunately not big enough to finish all the research. But after that, only TU and Radboud Medical Center are continuing with this project just on our own resources, students, and interested people who want to work on it. And even we succeed to make tests in clinical setting at the Radboud Medical Center. We did tests with 2 children, and now more are on their way. The problems are that children, when they are at the hospital first, they have problems with the pain after the operation, but also they are in a new environment. This environment can also cause stress, and the environment is boring and medical-like and scary. And so there are more things to think how to understand what is the real condition of the children. Are they stressed from the new environment, or they really have a pain? So we have to look at the whole process and introduce the robot early enough when they met the doctor much before the operation, because otherwise the measurements which we may measure and decide it is stress or pain could be just because of the novelty of the robot. So it's the whole trajectory we are looking at. And also with the children, there are many different problems which appear. We have to decide how to design the robot behaviors, of course, and how to make the children wear wearables. For example, the smart sock was chosen for people with heavy intellectual disability who are mainly static. They stay in a wheelchair or they lay, so they don't move a lot. But if you move a lot, then the physiological signals won't be that reliable. And also the children may not want to wear it. We have had also cases when people refuse to wear this wearable. So we were thinking how to create wearables which are appealing for the children, and we were thinking the topics of superhero, also because physiological signals are very well measured on the forehead and wrists. So the superhero suit might be a very good idea for that. And of course, the robot can have also the same suit, so the child is more eager to provide his physiological measurements to us. And of course, they can take a plushie at home, which is also full with the sensors, which can fool the pressure, strong pressure, which is also another indication of unhappy behavior for the child. Well, I can introduce you to the... I will skip introducing you to that because time goes always faster than we would like to. So just to mention one last project, the stress was measured also by children, especially children with autism, which are not aware that they might have stress. And our PhD student developed a pen, which if squeezed or pressed with it, will try to interpret the signals as the level of stress of the child. And we were lucky to get a patent on this pen. So if there are companies here interested to help us go further with that, we can work with the companies. So the pen gets physiological signals. We get also behavioral data and reports from the parents to estimate the level of pain. And on these nice graphs, you can see that we have some successes of correlations with reports and measurements. And of course, the next step, and this is the last slide I'll talk about, was making this pain also able to signal the level of stress. So it got a tail, like a cat tail, which shows the stress as the cat will do it. And the same student was very lucky to get the best design competition award for this pen. This is a social computing type of stress regulation, but I'm out of my time, so thank you very much for listening.
Thank you very much. Is there anybody that would like to ask a question to Emilia about this very interesting application of AI? We have time for one question, so. Let me see if I see a question anywhere.
Well, no question.
Don't feel the pressure because I say there's only one question, so. I see a question here on this side. All the other way.
Thank you for your presentation. I was wondering, have you looked at what if the system reports something different than the parents think, about the stress, for example,
Yes.
or pain, or?
Yes, the system often reports something different. That's why we are trying to get to introduce more modalities, more signals to get more reliable prediction. Of course, reporting that somebody has pain is kind of an error which we can live with if he doesn't have pain. Well, it's the problem is if the other type of errors when the person has pain and nobody knows about that. So we are more conscious about underreporting than overreporting.
It will influence our observational capabilities in the end, as humans?
I think yes, because if we have a reliable, almost reliable estimation of stress and pain, the parents, but also caregivers, especially new caregivers in a society when care system is very, very kind of overloaded. People have very little time to give care. Maybe if you know whom to attend, when, will be very useful.
Okay, thank you.
Okay, thank you very much. Very big applause, please, for Emilia Barakova.
Thank you.